Okay, so number 9 says an object falls freely from rest in a vacuum. So there are things that are important here. Freely from rest in a vacuum, meaning that the initial velocity, since it's from rest, the initial velocity it's a 0. So initial velocity is 0. Now freely, meaning that there is no air resistance and we are in a vacuum, so there is no air resistance. Now there's an implication there. When there is no air resistance, then the acceleration will be 9.81, which is acceleration due to gravity pointing downwards. But when there was air resistance, if something is falling, then the acceleration would decrease from 9.81 to 0 until it becomes 0. So here the question then continues. The graph shows the variation with time t of the velocity of the object. So how the velocity of the object is changing there. Which graph using the same scales would represent the object falling in air? As I told you, if the object is falling in air, then there's air resistance. Then the expectation is that the acceleration will gradually decrease until it becomes 0. So the graph that we are looking for is a velocity time graph, remember. So on a velocity time graph, the gradient represents acceleration. If the gradient represents acceleration and acceleration here is decreasing because there's air resistance from 9.81 to 0, then we expect a graph with a gradient which is decreasing until we get to 0. So where gradient is decreasing. So the options were very limited between the two. For example, this one would not work. Why? Because the gradient is a constant throughout here. So that one would not work. And this one also would not work because gradient is actually increasing, meaning that acceleration is increasing. So we were left with the two options. Now, the point is that it does not have to become exactly 0, ultimately to become 0, but we have two options here. Either it goes to 0, whatever the case, the gradient must be decreasing. So we have two options, this one and this one, B and C. So both of them seem pretty similar. The question then becomes, which one is the answer now? The answer is C, and we shall explain why the answer is C. Firstly, we were told that the velocity is starting from 0. So if velocity is starting from 0, we would expect the velocity to increase quickly when the acceleration is high. And as the acceleration decreases, then the velocity decreases. So I think that, okay, I second C here. C cannot be probably the proper answer because at first we should have a very steep gradient because the acceleration will be 9.81. So we need to reason out the question here. At first we must have an acceleration of, 9.81. But the reason why C is the answer, I didn't want to circle it all at once, is that this graph here, which was here, was already representing, they said that we are drawing on the same scales. So this graph was already representing the gradient that will be expected for an acceleration of 9.81. So the gradient that will be expected for an acceleration of 9.81, yes, that steepness, this steepness. But as you can see, this one, the initial acceleration, if it's 9.81, this one, it is too steep as compared to this one. So this one, the steepness here is in corresponding with the steepness here, showing that our acceleration, starting acceleration is 9.81. Because for when acceleration is constant and at 9.81, the gradient is like this. So B could not work even though B was having a graph with a decreasing gradient, which was representing a decreasing acceleration. It would not work because it had an acceleration greater than the acceleration of 9.81. Therefore, the answer was C because of that reason. So I removed C so that we could actually do the reasoning and determine which one was the answer. Then the next question, which was problematic, was number 10. A rock of mass m2m traveling in deep space at velocity v explodes into two parts of equal mass. So we have a rock of mass 2m. It was traveling in a deep space at a velocity v. It explodes into two equal masses. So if its mass was 2m, then now the two equal masses have mass m and m, one of which is then stationary. So the other mass becomes stationary. What is the kinetic energy of the moving part after explosion? So to find the kinetic energy of the moving part after explosion, obviously, we must use the principle of conservation of momentum. At first, this is of mass 2m, moving with a velocity v. Then after it explodes, two things happen. We now have smaller masses, another mass there. This one is still continuing to move. We must find its speed x so that we'll be able to determine its acceleration. It is a mass m, this one is a mass m. So the bottom part is showing after, the top part is showing before. So the principle of conservation of momentum, applying it, would then say that the total momentum before the interaction that happened here, the explosion, the splitting, was the mass, which was 2m, multiplied by the speed, which was 2v, a v. Then this is equal to the total momentum after. But this one here is becoming stationary. So its velocity is 0 finally. So its momentum will be m times 0, which is 0. So we are left with this one, whose momentum will be m times x. And we are looking for x, remember. So its momentum is m times x. We then divide both sides by m, this side by m. So dividing both sides by m, x is equals to 2v. So that is the velocity of the moving particle after the explosion is 2v. Now, knowing that its mass is m, then its kinetic energy will be half m times its speed squared. But its speed is 2v, so 2v squared like that. This becomes half m times 4v squared. Half 2 into 4, that's 2. So this becomes 2mv squared. So 2mv squared then represents our answer here of the kinetic energy after explosion. So the next question, which seemed to be a problem, was number 12. Number 12 was saying a cube of xyz has sides of length. This is the cube xyz here. Has sides of length 2 centimeters and mass 24 grams. The cube rests on a meter rule of negligible mass. The geometric center of the cube is vertically above the 70 centimeter mark on the scale. The cube has non-uniform density, so that its center of gravity is not at its geometric center. So they are saying that its center of gravity, even though the geometric center is somewhere here, which would correspond to 70, they are saying that the center of gravity is not at that particular point there. The center of gravity is not at that point because the cube is non-uniform. The center of gravity of the cube is in the plane of the diagram. Okay, so they are saying that the center of gravity is there in that diagram, in the plane of the diagram. The rule rests on a pivot at the 50 centimeter mark. A mass of 23.4 grams is placed vertical above the 30 centimeter mark. The rule is horizontal and in equilibrium. What can be determined about the position of the center of gravity of the cube? So we now need to determine the position of the center of gravity of the cube. So remember that at the center of gravity, that's where the weight of the object seems to be acting. So we want to find the distance from the 50 centimeter mark here to where the weight of the cube is acting. So what do? We find, since it is in equilibrium, then anti-clockwise moments are equal to clockwise moments. Of course, I could convert these masses, so 23.4 grams into kgs, and then multiply it by 9.81 to make it weight. But ultimately to cancel out both sides, so it's a waste of time. So I'm just going to say 23.4 multiplied by its distance from the pivot, which is 20 centimeters. I want to convert it also I'll just keep it like that. 20 centimeters, that's the moment due to this mass here. Remember this mass here, its way to be going vertically downwards. So if we are considering this pivot, then this one is providing an anti-clockwise moment, and this other mass is providing a clockwise moment. So the anti-clockwise moment is this one. Then this is equals to, now we don't know the distance from 50 where the center of gravity of this cube is, so we just call that one x, but we know that the mass of this one is 24. So we say 24 times what? Times x. So when you say 24 times x, then the next thing there is you divide, you say x is equals to 23.4 times 20 over 24. So once you divide this one, it is obvious to see that, I don't have a calculator here, but it is obvious to see that 23.4 divided by 24 will give us an answer which is less than 1. And then the answer that is less than 1, but approximately near 1, multiplied by 20 will give us an answer less than 20. So we'll get x. X is less than 20. For now, I don't have a calculator, so I will just proceed. So x is less than 20. So coming here, we can agree that the distance from 50 to where the center of gravity is less than 20. Now, the 70 centimeter mark is somewhere here. So from 50 to 70, that will be 20. But the center of gravity has been proven that it is less than what? The distance has to be less than 20 from 50 to the center of gravity, which means that it is somewhere there where we don't know its exact distance. So what would do say? We don't know the exact distance because I didn't calculate it, but I have a pretty good idea of what to do there. So then the other question was saying what can be determined about the position of the center of gravity of what is it? Of the cube. A was saying it must be somewhere along a horizontal line that is 0.5 centimeters from the line WX. So this one is considering that the center of gravity has to be somewhere along the horizontal line 0.5 from WX. Now that is wrong because it cannot be just be somewhere. Then it means that it is possible for it to be here. They are just saying that it is possible somewhere along that line there, which is wrong because then it will be possible to be any point along that horizontal line. Then the next one is saying it must be somewhere along the horizontal line 0.5 centimeters from YZ. YZ is horizontal here. So 0.5 centimeters from YZ. Then it would not make much sense anyway, because then it would mean that it is somewhere along that line. There is no justification for it to be somewhere along that line. We are not concerned about that. We are concerned about the center of gravity's distance from the pivot, which must be less than 70. Then the next one says, I will read D since I know that the answer is C. It must be somewhere along the vertical line 0.5 centimeters from XZ. So from XZ, 0.5 centimeters, then it will be somewhere along this line. It cannot work because then the distance from 50 will be more than 70 now. Why? We know that the size of this cube is 2 centimeters. So at the 70 centimeter mark there to 71, that's 1. So if it's in between 70 and 71, then 50 to that point will be more than 20, which would not work. So the final answer is that it must be somewhere along a vertical line that is 0.5 centimeters from line WY. The equation would be simpler than I just calculated, but I didn't have the calculator there.